Hello, dear participants of the 7th International Conference on Computational Linguistics and Intelligent Systems. My name is Artem, and I will present our current results on the research in the area of combining experimental and analytical methods for penetration testing of AI-powered robotic systems. Shortly, robots will be everywhere as companions for older adults, manufacturing workers, healthcare attendants, etc. Robotic systems must be secure, well protected, and hard to hack. If not, they could quickly become dangerous tools, capable of wreaking havoc and causing substantive harm to their surroundings and the humans they are designed to serve. On this slide, you can see 4 serious incidents related to unexpected robot behavior. These incidents expose the robot to the danger of being hacked. AI is playing an increasingly important role in robotics, enabling robots to perform tasks that would have been impossible or difficult to achieve without it. Nowadays, it's actively being used in robotics in such areas as neural language programming, computer vision, autonomous navigation, and machine learning. The goal of our research is to review existing methods of safety and cybersecurity assessment and develop methods combination to improve the penetration testing completeness, trustworthiness, and decrease its execution time and cost. The object under study is a collaborative robot in its architecture, component, technologies used, etc. During our study, we have researched various methods of safety and cybersecurity assessment. In this table, you can see that we separated them into 3 types: analytical, experimental, and experimental. To the analytical group, we separated risk and vulnerability assessment and attack tree analysis. To the experimental analytical group, we separated intrusion, failures, mods, and effects criticality analysis. And in the experimental group, we separated penetration testing and faults and variabilities injection testing. Risk and vulnerability assessment is often used method to identify and evaluate potential weaknesses and vulnerabilities in a system to develop a plan to address and mitigate these vulnerabilities and maintain ongoing security. Attack tree analysis provides a formal, methodological way of describing the security of systems based on varying attacks. It represents attacks against a system in a tree structure with the goal as the root node and different ways of achieving that goal as a leaf nodes. Intrusion modes and effect criticality analysis is aimed at showing the characteristics of the system as availability, security, and vulnerability through using 2 techniques, the MECA and F-MECA. Penetration testing is a widely used methodological approach that allows assessing the security of a system by simulating a real attack. Faults and variabilities injection testing is a commonly used experimental technique to assess the dependability of microprocessor-based systems such as robotic systems. During our research, we analyzed each method stages and separated them into 8 groups: preprocessing, system preparation, threat analysis, threat modeling, criticality analysis, access control, mitigation, and post-processing. Using these groups, we developed 4 analytical and experimental methods combination with the penetration testing: MECA pen, ATA pen, R&VA pen, F&VIT pen. These combinations are aimed to reduce execution time, improve the completeness, trustworthiness, and decrease the cost of safety and cybersecurity assessment. All robotic system attack surfaces such as robot service networks, controller, program tests can be assessed using MECA pen. This combination allows the pentester to assess and perform intrusion failure analysis and assess findings criticality after each penetration testing phase. In this table, we summarize the advantages and disadvantages of MECA pen. So advantages are as follows. Pentester can predict the impact of vulnerabilities he found without exploitation of these findings. In cases when the goal is assessing the impact of possible threats, this method's combination can save a lot of time by excluding the low criticality scenarios from the testing scope. When access to the robotic system is gained, the pentester can redo the MECA analysis again to identify the most critical threats and begin the exploitation process from them. Might be very helpful also after regression testing to understand the level of risk mitigation. Disadvantages are follows. Vulnerabilities can be known issues that refer the pentester to the vulnerability database like NVD with already assigned CVE, assess criticality level of findings, and describe the steps to exploit, and there is no critical need for criticality analysis before the exploitation. If access to the system is gained for a very short period, pentesting might have no time to perform an MECA analysis. ATA-PEN is an often used technique as an addition to the penetration testing activities, especially after the scanning stage. It adds such stages as identifying potential threats, creating attack trees, and analyze each node of them. In this table, we summarize the advantages and disadvantages of ATA-PEN. So, advantages are follows. First, ATA-PEN helps pentester to identify possible attack vectors on the robotic systems, like robot, networks, controller, or program task, and analyze their components to understand the way to perform an intrusion into the robotic system. Second, applied countermeasures can be validated using ATA-PEN method combinations. If we talk about disadvantages, there are only one serious disadvantage. ATA-PEN requires extra time for creating attack trees. R&VA PEN combination of methods is so widespread that sometimes penetration testing is confused with vulnerability assessment and vice versa. This combination is a very large-scale and long-time consuming process that covers not only safety cybersecurity assessment, but also vulnerability monitoring and reporting activities. In this table, we summarized advantages and disadvantages of R&VA PEN, and advantages are follows. The method has the largest testing coverage. Also, this method simplifies mitigations of the false positive findings by verifying them using exploitation activities. To the disadvantages, we can mention cost, that it is cost and time-consuming method. The unique stage of F&VIT PEN method is an injection stage. This technique may be useful to test the completeness and trustworthiness of the penetration testing process. The idea is that development teams inject certain known vulnerabilities before starting the testing phase, and pentesters must check how the robotic system will react to their appearance and what exactly they can lead to. Method is quite risky because fault or vulnerability injection can lead to unexpected robotic system behavior, so it's not recommended to perform it on a real existing system. In this table, we summarized advantages and disadvantages of F&VIT PEN method. Advantages are the following. First, F&VIT PEN method allows for the assessment of the quality of pentesters' work. Second, development team can see how robotic system will work in unexpected critical situations. Disadvantages are follows. This method is risky if used in real robotic systems condition. It's a time-consuming method, and also it requires robotic system simulator to be used for testing. Based on the analysis of possible option of combining existing methods of ensuring the safety and cybersecurity of robotic system and review of advantages and disadvantages of these methods, it is possible to build a generalized matrix of influence on certain aspects of penetration testing. We evaluated the impact methods combining on the penetration testing matrix such as completeness, trustworthiness, execution time, and cost, using the scale from -2 to 2, where -2 is a significant decrease in this metric, -1 is a slight decrease in the metric, 0 means that value of the metric doesn't change, 1 is a slight increase in the metric, 2 is a significant increase in the metric. Also, it's important to notice that before the evaluation, all the metric score values are equal to 0. As a result, we noticed that MECA pen doesn't significantly increase the execution time and cost of penetration testing, but incomparably improves its completeness and trustworthiness. ATA-PEN combination also raises penetration testing execution time and cost, but also slightly improves its completeness and trustworthiness. R&VA is a very cost and time-consuming method combination, but it significantly improves penetration testing completeness. FBI-PEN is a method combination which requires an additional environment to be used for penetration testing, but this method can significantly improve robotic system dependability. So, during this study, we analyzed a few analytical and experimental methods of safety and cybersecurity assessment methods to be combined with penetration testing and evaluated them. As a preliminary result, we have determined that the combination of MECA with penetration testing is the best of considered ones, but requires practical confirmation in the condition of application in a real robotic system or its simulator. Future research can be dedicated to, firstly, the addition of the methods and analysis of their extended combination, and secondly, simulation and field investigation of the robotic system cyber security assessment using the suggested approach. Finally, it will be interesting to continue research on cybersecurity analysis and assurance issues for the Internet of Robots as a part of IoT systems. Thank you for your attention.